the eye, and it doesn't need a backlight. It's also much more responsive, offering anywhere between 1 and 60 frames per second. And that means that it can also run video. When was the last time you saw an e-book reader shift ink around the page at that speed?
I think the key thing here is that we actually bring the best of both worlds together. On the one side, there's the LCDs. They bring video, they bring color, we know that from our TV screens. And on the other side, there's the electrophoretic displays, which bring low power consumption and readability under all lighting conditions. None of these technologies brings both of these together, and that's what we do.
So how is the speed and color achieved? The technology inside these screens is called electrowetting, and it's coloured oil that's being used rather than ink. In a normal e-reader, the black ink is pulled to the surface or pushed into the background by electromagnetic charges, creating the black and white display. An LCD screen works differently. Liquid crystal displays, like our laptops, have several colour filters and need a backlight. A gate opens to allow the light to shine through the relevant filters, but here just a third of the backlight is used to provide a red pixel. With electrowetting, 3 layers of coloured oils are pushed back and forth to create the specific colours. The advantage is that much more of the backlight passes through each pixel, which helps make the screen 3 to 4 times more efficient. And just like a black and white e-reader, it works without a backlight as well. While LCDs compete against sunlight, these screens bounce that light through the oil filters back at the reader. So the brighter the sunshine, the brighter the screen. And that switch between reading in sunlight or in the dark can be managed automatically. The refresh rate needed to achieve movement means these screens use more power than a classic e-reader. The company ultimately sees them as replacing all the screens we use. This is still work in progress. The colour experience isn't quite as sharp as existing e-readers, and video, especially fast-moving video, can leave some aberrations on the screen, a sort of ghosting effect, which the company is working on to reduce. Despite the excitement around colour e-readers that play video, it's perhaps the efficiencies of electrowetting that hold the greatest potential for this technology. Eventually, if placed into laptops, these screens could deliver battery lives measured in days rather than hours.
Electricity is not freely available everywhere in developing countries. So it means, of course, if you can run this device for a long time on your batteries, that's great. And secondly, the world is asking really for greener products. Now, greener products means low power consumption. That's exactly what electrowetting is giving the country.
Liquavista is in talks with electronics manufacturers who will have to decide whether to invest in this technology. But in the longer term, it's working towards something much more sci-fi. Together with UK e-reader firm Plastic Logic, it hopes to produce a flexible colour magazine that can update itself and run video within 3 years.